Hey folks, it is Thursday/Friday. This is the second lesson for the week. We are going to be moving on to section 1.2. Last week and earlier this week we covered line segments and all about line segments and midpoints of line segments. Now we're moving on to angles. So again, anything in blue I highly recommend you write down. Today at the start of this we've got learning target. Again, write that down at the top so that you know what your notes are about, all right? So learning target for today, I can define parts of angles and measure angles. I said angles twice in that sentence, but that's okay. Today we're talking about angles, just the basics of them. And for success criteria, you'll be successful when you know you can name, classify, and measure angles. And we won't be constructing anything today since you guys are at home. That's totally fine. Use linear equations to represent and solve problems using angle relationships. Pause if you need to get that down, and we're going. So, parts of an angle and how to name them. Check it out. We got things in blue, and we have a diagram. Might be a good idea to get that down. So, here's an angle, all right? And what do we have? First part of our angle is they're made up of rays. So again, rays have an endpoint and they continue forever in one direction. Here, I've got an endpoint and I'm naming that point A. So here's my endpoint and I'm continuing in that direction forever. Let's call that point B right there. And I'll have a point C. So I can see that my angles are being made up of two rays put together and the rays are sharing their endpoints. I'm gonna name the rays. After this, actually, I'm going to say the rays, think of them as like the sides of your angle. And here our rays are AC and AB. Okay, and then the other part of our angle is the vertex. Again, like the end point, this is another fancy word that we will be using throughout the semester. So our end point or our vertex of the angle is the part that the rays share. So they share this end point or vertex, again, new word, A. So again, I'm just going to say rays share vertex. And here in the example, again, that vertex, we're calling it point A. And then another thing I want to point out is adjacent angles. Adjacent, whenever you think of adjacent, I like to think of like two things right next to each other. So here's like a box, here is an adjacent box. Or maybe you're giving directions to someone and you want them to go to the adjacent corner on the street. You're on this corner, they would be on the other corner. Adjacent, think of like next to. So I'm going to say adjacent, next to. So here if we're talking about angles, adjacent angles, we're talking about angles that are next to each other. Adjacent angles share a ray. They share a side. So if I had to draw an adjacent angle to this, I'm just going to sketch one on the diagram and say, let's go with this angle here. I made a new ray off of point A, so I have a new ray AD. And I can say that this angle and this angle right here are both adjacent. They share a common ray of ray AB. Okay? Just for the next part, I'm going to erase this adjacent angle. Erase my point. All right, and then there's a couple different ways that we can name our angle so we know exactly what we're talking about in a diagram. So the first easy way is just name it by the vertex. Boom, it's got a vertex A. I'm just going to call it angle A. That's how we know we're talking about this angle right here. So you can name it by the vertex. I'm going to call this angle A. We like to have that little guy there so we know we're talking about an angle. Kind of like last week we used the line notation on top of 2 points to indicate that we were talking about a line or a ray or a line segment. Here we just add a little mini angle in front of our vertex. Or we can name it sometimes in diagrams to make it easier, we'll just put a number in it. So here I have number 1. We could just call this angle 1. Again, if there's no number, just use the vertex, but sometimes you'll see we're talking about angle 1, angle 2, and angle 4 or 3, right? So another way you could do it is by number. Okay, so by number, and again here we could just call that angle 1. Again, I'm adding that miniature angle at the front. And the third way, probably the most common way, is to use 3 points to name your angle. This is probably the best way if you have multiple angles that you're talking about. Maybe you have adjacent angles and they share a common ray. So again, if I added that adjacent angle there, and I said, what about angle A? And then you'd be like, which angle A are we talking about? Because they both share the same vertex, right? If I just say angle A, am I talking about this one or am I talking about this one here? So if there's like a lot of things going on in your picture, we usually just like to use 3 letters. So here, if I want to talk about this angle right now, I could say angle BAC. And we always start our angles, naming our angles, with one of the points on the ray, and then we go to the vertex, and then we end with another point on the other ray. So I think you can see, I'm also going to say by 3 points. Here I'm going to say angle BAC. We could also name it angle CAB or angle CAB. It's the same thing as long as that middle letter is the vertex, all right? So again, the name or the outside points that are on the ray, those don't really matter, but that middle one needs to be your vertex, all right? Because if I say angle CBA, I'm looking at B to be my vertex, and there's no angle being made here, all right? So take a second, pause if you need to, parts of an angle and how to name them. Moving on, here we go. You guys doing good? All right, classifying angles. So now we're going to be looking at, this stuff should be also reviewed to some point. Classifying angles, now we're looking at their measure. And when we're talking about the measure of angles, we can also put an M in front of that little miniature angle that we drew. So if I wanted to know what's the measure of angle A, I can just put a little M in front and now it says measure. So this just says angle A. Now it says we're talking about the measure of angle A, all right? So acute angles, if they're acute, they're small, they're smaller than 90 degrees, all right? So acute, I'm just gonna use angle A. You could use angle P, angle R, whatever you want. If the measure of angle A is greater than 0, but less than 90, and I'll add little degree signs on there, then we can call that an acute angle, all right? So if the measure of angle A, if it's greater than 0, but less than 90, then it is acute. Maybe these are sounding familiar. I'm gonna get rid of this arrow. My right angles are exactly at 90 degrees. Corner of a piece of paper, corner of a book, right? Corner of a house. We measure things with 90 degrees if they're right angles. So here, you can classify angle A to be right if the measure of angle A is equal to 90 degrees. Obtuse angle, anything greater than 90 degrees. all right? But less than 180. So here's measure of angle A. It's going to be obtuse if the measure of angle A is greater than 90, but less than 180. All right, hopefully these are words you've heard before. Straight angle is, just think of a straight line, literally. A straight line, and you measure that to be 180 degrees. All right, so straight lines, 180 degrees. So if the measure of angle A is equal to 180, you have a straight angle. All right, this is not going to be going away anytime soon. Make sure you know what straight angle means. Reflex angle, we won't talk too much about it, but again, reflex is anything now greater than 180 degrees. So if you got an angle A, if that measure of angle A is greater than 180, then you've got a reflex angle. Kind of ran out of room there. I'm going to draw a quick picture on the other side for each of these. If you want to get that down as well, maybe you need a pause. So acute, I'm going to get rid of that. Here's my little pictures of my acute angle. All right, definitely smaller than 90 degrees. My right angle equal to 90 degrees. Okay, that looks about 90 degrees. And if we want to specify that that thing is a right angle, that it measures 90 degrees, we can add this special little box in the corner. As soon as you see that little box in a diagram, you know that that angle has to have a measure of 90 degrees, all right? That's another special little way we can do that. Obtuse angles, anything, that's a really long ray. Anything greater than greater than 90 but less than 180, so that is obtuse. Your straight angle, again, literally a straight line. Okay, so maybe here is your vertex. Literally, these rays would be pointing in the opposite direction of each other. And if you think about it, a circle is 360, so half of a circle, right? If we're measuring this angle, half of a circle would be half of 360, which is 180, all right? And then reflex angle. All right, it looks similar to an acute, but we would be measuring this angle. Okay, so we would be measuring like the outside. Here would be the measure for your obtuse. Here would be the measure for your acute angle. Pause and sketch things as need be. We're moving on. Where's my mouse? There it is. Okay, whew, that was a lot. Let's name some angles and classify them real quick, all right? I'm just going to throw some out there. Feel free to name some if I don't as well. I've got angle DCE. Again, it has a vertex of C, but I can't just name it angle C because look at how many other angles are shared with that same vertex, right? So here I have to use more than one letter to name that. So I'm going to say angle DCE. What about angle ECD? That is the same thing as well. Angle ACB. All of these right here are acute angles. Let's think about, I don't have anything that's marked right angle, but if I added into my diagram something that looks like that, then I could say that angle DCB is a right angle, or angle BCD. What about some obtuse angles? ECB. A lot of different letters here. Hang in there with me. DCA. I'll put that one down as obtuse. Again, take a second, name any others. Try and see if you can find a straight angle. All right? Take a second, find a straight angle. straight angle ACE. All right, even though it's a straight line, now we're talking about this angle. So we got to have that little angle sign. We have our points that are on our rays, and we have the vertex of the angle C. Okay, let's move on. All right, supplementary versus complementary. Two angles are considered supplementary. Hopefully you've heard this before. I really hope you have. Two angles are supplementary if the sum of their measures equal 180 degrees. So now we're talking about adding two measurements together, and if you've got an angle that's measured 100 degrees and you've got an angle that's measured 80 degrees, well, those would be considered supplementary angles because adding their measures together gets you 180 degrees. So if I said, let's say I've got angle P and angle M. If angle P plus, or excuse me, now we're talking about the measure, right? If the measure of angle P plus the measure of angle M equals 180 degrees, then again, they're called supplementary. Down here, two measures are complementary. Now, instead of 180, if they add up to 90 degrees. So, the measure of angle P plus some measure of angle M are complementary if their sum is 90 degrees. And I'll write that out for you. Sum of their measures or measurements is equal to 90 degrees. All right. Again, these are not going to be going away anytime soon. We're going to be using these all year. Supplementary, 180 degrees. Complementary, 90 degrees. The way that I can remember these, wow, I sound like Dr. Seuss or something. Supplementary, if you look at that word, supplementary, supper. Think of supper. After you've had a really big supper, you want to lie down, right? After you had a lot of food, you got to go lie down and just rest. Am I right? After Thanksgiving? So if you're lying down, you could be considered a straight angle, which we know measures 90 degrees, or excuse me, 180 degrees, all right? So if you've just had supper, you're laying down, you're at 180 degrees, supplementary angles. The other way I think about complementary, when you compliment somebody, you're being nice, you're being respectful, you're being right. Like that is the right thing to do, is to compliment somebody. So if you compliment somebody, you are right. If you are complementary angles, you add up to be a right angle. You add up to be 90 degrees. That might be two ways that you want to keep that in your head. Pause if you need to. We're moving on. All right, I've got a couple more things left. We're doing good. Okay, just a quick example. If P is supplementary to angle Q and you know that angle Q is 180 degrees, we're looking to find the measure of P. Can I draw a quick picture of this? Yeah, let's do that. Supplementary. After you had a big supper, you want to lay down. So here is a straight angle, because I know supplementary angles add to 180 degrees. Let's just throw another ray out there, all right? And maybe this is angle P and this is angle Q or something. And I got, Q is 180 or 110. Let's switch those so it makes sense. All right, so that's kind of a good little sketch of what's going on. And I'm also given some information that angle Q is 110 degrees. And I'm wondering, what is the measure of angle P? Well, if just by looking at it, you could say if this entire thing is 180, and I know that part of it is 110, just subtract 180 minus 110, and that gives you 70 degrees. So the measure of angle P is 70 degrees. If you want to, you could also set up an equation and say, and we're going to get to this in just a second, you could say that 110 plus whatever the measure of angle P is has to be equal to 180. And then you could solve from here, minus 110 from both sides. We're doing the same processes over there, and you would get that measure of angle P equals 70. Pause if you need to. All right, what we just did back on that last slide was kind of a introduction to the, angle addition postulate. I should have put that in blue. Highly recommend you get this down. Pause if you need to. Same as the segment addition postulate, the angle addition postulate, if we have a big angle, so here if we're looking at this entire angle, basically it says that part of the angle plus the other part of the angle is going to be equal to the entire angle. So let's kind of break this little puppy down. And it says if point S is interior to angle PQR, so again, PQR, kind of this really big angle. If I have point S somewhere inside of that angle, then, now this looks a lot, hopefully you wrote this down, the measure of PQR, so this entire thing, is equal to the measure of PQS. PQS is here. Let me see if my purple works. Barely. All right, so that's PQS. And plus the measure of SQR, so here's SQR. All right, see all of those parts of the angle being broken down? Again, it's called a postulate. We can accept it without any proof. I mean, this just makes sense, right? The part plus the other part has to equal the whole. Now we're just talking it with angles, all right? So pause if you need to. I think I have an example of this. Yep. So let's kind of break this down again. I have measure of angle AOC. AOC, so this entire angle is 60 degrees. And I know that BOC, this smaller part, is 25. The entire thing is 60. What is the measure of AOB? All right, now we're looking for this little part. So, what is that? Again, you can set up an equation by just saying, let's just let this be the measure of AOB. Plus 25, the other part of your angle. Has to be equal to 60. That is the entire angle, okay? And then, I mean, we can just solve this here and say, all right, minus 25 from both sides. Oops. Cancel that out, and now we're just left with the measure of angle AOB is equal to 35, okay? There we go, because we got that 35 plus that 25 has to give us the whole of 60. Okay, I think that was it that I have for today, so please let me know if you have any questions. Yep, all right. So that was all I got. Go back and see if you need to get any more notes down. Clocking in at about 25 minutes, so 35 minutes after we've started class, go to Blackman 107. Be ready for some review questions. See you soon.